Hello, geometry. This is Q4 week 3, and this is your examples video. If you have not watched the video on the vocabulary, please watch that one first. Watch this video second. So this week we are going to be working on finding the length of an arc. Not in degrees, but in things like inches, miles, so units of length, not units of angle measure. So this is related to last week when we were working on the area of a sector. So when we find the area of a sector, what we're doing is we're finding like a fraction of the area of the circle or a percent of the area of a circle. What we're doing when we're finding the length of an arc is we're finding a fraction of the circumference of a circle or a percent of the circumference of a circle. So let's look at an example. So let's say I have a circle. This is circle P. And I need to find the circumference of it. So the circumference formula is 2 times pi times the radius. Or we have another version that we can use. Circumference is equal to pi times the diameter. So, in this circle over here, circle P, we have a radius, PQ, and the radius is 3 centimeters. We have another radius over here, PR, and we have one more piece of information we need to know. We know that the measure of angle RPQ is equal to 120 degrees. So if I want to find the length of an arc is a piece of a circle. The arc is created by this angle RPQ. So arc RQ is this piece right here that goes between point R and point Q on the circumference. So I'm going to say, find the measure of arc RQ. So this is going to be very similar to how we found the area of a sector. We're going to do a new formula for the length of an arc. So that formula, length of an arc, is equal to theta, that's the angle, divided by 360, times the circumference. So I want to know what fraction of the circle is this, times the circumference, so times 2 pi r. So, looking at this example, I have everything that I need to know to be able to do this. So, theta, this angle 120 degrees is my theta out of 360, and my radius right here is given to me. That is this 3 centimeters. So I'm going to plug this information in. The length of the arc is equal to 120 degrees divided by 360 degrees times 2 times pi times 3 centimeters. So if I work this out and simplify it, the length of the arc is equal to, well, my zeros cancel out, so that's 12 over 36, which simplifies to 1 over 3, times 2 times 3 is 6 pi. So I can say this is like 6 pi over 3. Simplify that one step further. 6 divided by 3 is going to give me 2. So 2 pi. That is the length of arc RQ. So the length of RQ is 2 pi centimeters. I can multiply that out and it will give me 6.28 centimeters. I will accept either of these answers, whatever you need. So let's look at one more example and get a little bit of space over here. Okay, so you are making a card to send to a friend. How much ribbon will you need to go around the outside edge of the card as seen in the diagram? Okay, so what does this card look like? So we're going to draw a shape like this. So you're making this card for a friend because you haven't seen them in a while because we've all been stuck at home. So your card is like a rectangle shape, but then it's got a circular semicircle arc on top. And so you want to put ribbon all the way around this outside edge right here that I'm drawing in red. This is going to be ribbon. Because you're crafty and you want it to look nice. Alright, so we need some information. So we need to know a few measurements on here. So this distance right here from one side of the card to the other, that is 5 inches. And this distance, just the height of the rectangular piece, which is here and here, that is 7 inches. So now we need to figure out how much ribbon. So this side is also 7 inches. This side is 5 inches. I can pretty easily figure out this rectangular piece. So I have 3 sides of the rectangle because I'm not putting ribbon. No ribbon here. No ribbon through the middle, but I'm putting ribbon on the outside edges. So I've got this 7-inch piece. This is a 5-inch piece. This is another 7-inch piece of ribbon. Plus this piece right here at the top. Plus the arc. So if I can figure out the length of the ribbon that goes on this arc, then I can add these 4 things together and I'll have the length of ribbon. So I said earlier, this is a semicircle. How many degrees are in a semicircle? 180 degrees. What is our radius here? So if this is a circle, what is this radius? Well, the radius is half of the diameter, so it's going to be 5 inches divided by 2, which is 2.5 inches. So now I've got everything that I need to plug in to my formula. So I'm going to rewrite my formula. The length of an arc is equal to theta over 360 times 2 times pi times the radius. Okay, let's plug these things in. The length of the arc is equal to 180 over 360 times 2 times pi times 2.5. Okay. Those zeros cancel out. 18 divided by 36, that's 1/2. And then 2 times 5, 2.5 is 5. So 1/2 times 5 pi. So that is 5 over 2 times pi, or 2.5 pi. If I multiply 2.5 times pi, I'll get about 7.85. For this type of problem, I'm going to prefer that my answer is in this form because I need to, if you remember, add these four numbers. So I'm going to do 7 plus 5 plus 7 plus the length of the arc. So my final answer to figure out how much ribbon do I need, I'm going to do 7 plus 5 plus 7 plus 7.85. And that will tell me the... So 7 plus 5 plus 7 plus 7.85 gives me 26.85 inches of ribbon. So 26.85 inches of ribbon. I'm going to go back up to that diagram. If I want to put ribbon all the way around the outside of the arc and 3 sides of the rectangle, I'm going to need 26.85 inches. Okay, that is our final example for today. Make sure you take notes, write down any questions you have, and I will see you on Zoom soon.